Hey, I'm Trevor, and I love programming. I wanted to share my love with everyone, so I created this channel. So let's get into the lesson. Hello, everyone. Welcome back. Today I am going to be going over floats, doubles, and decimals. So let's go ahead and create a new project. Console app.NET Core, and I am going to label my floats underscore doubles underscore decimals. And let's hit create. Alrighty, so let's get started. So floats, doubles, and decimals are very similar to integers, except for they deal with a decimal within the number, or they can deal with a decimal within the number. So to start off with a float, we do float f equals 2.45. And if you put a semicolon there, you'll notice that we're going to get an error. And if you hover over it, it's just saying literal of type double cannot be converted to type float. You have to use an F suffix to create a literal of this type. So what Visual Studio does, anything that has a decimal in it is automatically picked up as a double. So in order to tell it that we are using a float, we have to put an F at the end of it. And that goes for any time you're trying to change it as well. So if you do F equals 3.45 and you put a semicolon, you're still going to get the same error. So we need to put an F there. It can be a lowercase f and you won't get an error, but I like to just keep capital letters there just to make it easier and make it more consistent throughout the rest of my code. So a float will display 6 to 9 digits, including the decimal. So if we made this number super long, no matter how long we make it, and we print out our float and you hit run, it's only going to print out 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 digits right there. So no matter how long you make it, it's only going to print out 9 digits. And the reason I'm going over all these on the same one is because whenever you're going through focusing on memory management, or your system in general just doesn't have a lot of memory, which in 2020 it's harder for that to happen. But now you want to focus on memory management. Well, let me get back. If you need to focus on memory management, you choose the one that is best suited for you. So if you only need 6 to 9 digits of precision and you're low on memory, a float would be the best choice for you to go with. If you're dealing with decimals anyway. If you're not dealing with decimals, then you can use an integer. And if you want to see just how big a float can be, we can do float f equals float dot max value. And let's go ahead and do the float g equals float dot min value. So you can just see exactly how big they both are, or how big both ways it can go. So if you run it, you're going to see that it can be a very big number. It can be 38 places to the right of the decimal, and as well as negative the same way. So now let's go ahead and move on to doubles. Doubles are the most common because if you see, you'll do double D equals 2.45 semicolon. And when you initialize it, it does not need the letter. Like I said at the beginning, Visual Studio automatically picks anything with a decimal up as a double. So, but for best practice, when you need to tell it what it's going to be again, like if you need to set it equal to something else, let's do 3.45. You're still not going to get an error, but for best practice, it's always good to go ahead and put that D, the capital D, or you can do lowercase. It's not going to give you an error with lowercase, but I tend to like to put the letter there just so my code looks cleaner, and the longer your code is, It's just easier to identify whether it's a float or a decimal. So that way, if you're having the memory management issues, you can go and change it, the type to a float or a decimal or anything, below. And a double will print 15 to 7 digits, including the decimal. So let's make this long again. And if you type, let's go ahead and print it out. Let's run it. As you can see, it's only going to print out 15 to 17 digits. This is 17 digits. If you want to, you can count it, including the decimal. And if you want to see exactly how big a double is, this is another reason why double is most common, is because it can be quite large. So let's do double D double dot max value. And forgot the max value. Double E equals double dot min value. And let's print out both D and E. So E, and let's run it. So now you see it can be 308 digits. We can move, yeah, it's saying that we can move this decimal 308 digits to the right. So this number can be huge whenever you're doing calculations, if you need to be super precise. So the last one I'm going to go over is bugging me slightly. Let's put a space right there. And then we're going to go over decimals. Decimals are a little different. They can't be as huge as a double, but they display more precise in the console. So if you're doing decimal, let's do decimal m equals 2.45. And if you notice, there's going to be an error. And if you hover over it, it's going to tell us that we need to use the m suffix. So the same thing for the float, except we need to use an m as a suffix. And that's how you let the system know that it's a decimal. So if you need to set it equal to something else, so let's do 3.45, you still need to put that in or you're going to get the error. So let's go ahead and make it super long. And, see, forgot my m, and it's giving me the error. So let's go ahead and print it out and run it. And you can see it's going to be 29 digits long, including the decimal. So it's really precise if you need to know the numbers printed out to be that exact. But if you do like we've been doing up there, and do decimal dot max value, and let's do decimal n equals decimal dot min value. Let's go ahead and delete this line. You can do so with your keyboard by hitting Control X. Do it right here. And do enter again, CW, print out N, and let's hit run. As you can see, it's a whole number. And that's because decimals had to be like saying that it's already a decimal before you're printing out. The max value isn't a whole number, just showing you that it's displaying 28 to 29 digits, and it's not as big as a double with a decimal. So a double can be a pretty like super long calculations wise. Just the decimal isn't going to be as long. It's just better for precision that needs to be presented. All right, and as you can tell, these numbers get pretty big. And the last thing I wanted to introduce to you is a digit separator. And this is used for whenever you need to, or you want to make your code cleaner and make the numbers more presentable when you're reading it. So let's just use an integer for an example. So integer, let's say we want to make this 300 million. So let's do 3, 1, 2, 1, 2, 3, 1, 2, 3. And when you're looking at that, oh, I forgot to initialize it correctly. Integer I equals 300 million. Now, when you're looking at that, you can't just look at it until it's 300 million. So to make this easier to read, we use these things called digit separators, which is an underline. And it's easier for you to tell. It's like a comma, but in code, it's a underscore. So when we print it out, it is it's still going to show 300 million, but without the underscores. It's just that when you're looking at it, you're able to, you can separate it with underscores. That way you know just how big the numbers really are. All right, that's all I have for today. If you found this video useful, like, comment, subscribe. If you have any issues, be sure to comment below. I'll have the notes included in a Google Docs that everyone can look at in the description, as well as the Discord if you want to join. And we have general chat there and a questions channel that if you're having specific issues with something, feel free to post it and I'll be able to help you there. And I'll see you in the next video. Thank you.